Humans are preparing to live on another planet, not in a distant future, not in science fiction. Right now, rockets are being built, missions are being planned, entire industries are forming around one idea. Mars will be our second home. But there is a problem no one likes to talk about. It is not about technology, it is not about money, it is not even about distance. It is about physics. And physics does not negotiate. Even if humans solve oxygen, even if food can be grown, even if massive shelters are built under the Martian surface, something deeper still remains, something built into the planet itself, something that quietly breaks the possibility of long-term survival. Mars is often called humanity's backup planet, a safety net, a place to go if Earth becomes unlivable. This idea has spread everywhere. It feels logical. Mars is close. It has land, it has ice, it has day and night cycles similar to Earth. From a distance, it looks like a second chance. This belief has driven some of the most powerful people on Earth. Billionaires are investing billions into rockets and habitats. Space agencies are planning missions that aim to send humans within the next decades. Private companies are designing entire systems for life on Mars. The goal is clear, not just to visit Mars, to stay there. At first, it sounds possible. Build sealed habitats, bring oxygen, grow food in controlled environments, use advanced technology to recreate Earth conditions in small pockets. Step by step, it begins to look achievable. But this is where things start to fall apart. Because Mars is not just another place with harsh weather, it is a fundamentally different world. A world shaped by billions of years of planetary changes that cannot be reversed easily. Most people focus on the obvious challenges, the cold, the thin air, the dust storms. These are real problems, but they are not the deepest ones. The real barriers are invisible. They are written into the structure of the planet itself, and this is where scientists begin to raise serious doubts. Physicists like Brian Greene explain that the universe operates on fixed laws. These laws define what is possible and what is not. They do not care about human ambition. They do not bend for engineering solutions. Mars follows those same laws, and those laws may be the real reason humans will never truly survive there long term. Here is something most people do not realize. Mars used to be very different. Billions of years ago, it had a thicker atmosphere. It had liquid water on its surface. It may have looked more like Earth than it does today. For a brief period in cosmic time, Mars might have been habitable, but something changed. The planet lost its magnetic field. Without that invisible shield, solar radiation began stripping away its atmosphere, slowly, relentlessly. Over millions of years, the air thinned, the water disappeared, the surface became exposed to intense radiation. Mars did not just become harsh, it became dead, and this process is not something humans can easily reverse. This is not like building a city in a desert on Earth. This is trying to rebuild an entire planet from the inside out. Even the idea of terraforming Mars, turning it into a more Earth-like world, runs into serious limits. There is simply not enough gas left on the planet to create a thick atmosphere, and even if there was, the sun would strip it away again. This is not a temporary problem, this is a permanent condition, and it leads to a deeper question. Not can humans go to Mars. Humans can go. That part is already within reach. The real question is much harder. Can humans truly live there for generations? Can a human body, shaped by millions of years on Earth, adapt to a world with weaker gravity, constant radiation, and almost no atmosphere? Can a human mind handle a life cut off from Earth, living inside artificial environments forever? And more importantly, can technology overcome the fundamental limits set by physics? These are the questions that rarely make headlines because the dream of Mars is powerful. It feels like progress, it feels like survival, it feels like the next step for humanity. But beneath that dream is a reality that is far less forgiving. Mars does not care about human plans, it does not care about ambition or innovation. It follows the rules of the universe. And those rules may be the biggest obstacle of all. In this video, you will learn the real reasons why long-term survival on Mars may never be possible. Not because humans are not advanced enough, but because the planet itself may be fundamentally incompatible with human life. You will see why solving oxygen, food, and shelter is only the beginning. Why radiation could silently destroy future colonies, why the human body may slowly fail in ways that cannot be fixed, and why the deeper physics of Mars creates limits that no technology can fully overcome. By the end, the idea of Mars as a second home may look very different, and the importance of Earth may feel much greater than before. Welcome to the channel. If you want to explore the deepest truths about space, physics, and the future of humanity, make sure to subscribe. From far away, Mars looks familiar. A reddish world with land, valleys, and frozen caps at the poles. It has seasons. It has day and night. The length of a day is close to Earth. This small detail alone makes it feel almost welcoming. This is where the illusion begins, because the similarities are only surface deep. That thin blue line around Earth, the atmosphere, is the reason life exists here. On Mars, that layer is almost gone. The atmospheric pressure on Mars is less than 1% of Earth. It is so low that the human body cannot function in open air for more than seconds. Blood would begin to boil, not from heat, but from lack of pressure. This is not a slow danger. This is immediate. Even the air itself tells the same story. Mars is made of mostly carbon dioxide. Oxygen is nearly absent. Breathing is impossible without full life support systems. Every breath would depend on machines working perfectly at all times, and machines fail. Temperature adds another layer to this problem. Mars is cold, not just cold in a normal sense. The average temperature is around minus 60 degrees Celsius. At night, it can drop far lower. Near the poles, it can reach levels that freeze carbon dioxide directly out of the air. This creates dry ice snowfall. Yes, snow on Mars exists, but it is not water. It is frozen gas falling through a thin, lifeless sky. Even during the day, temperature swings are extreme. The thin atmosphere cannot hold heat. A relatively mild afternoon can quickly turn into a freezing night. There is no stability, no balance. Water, the foundation of life, faces its own problem. Mars does have water, but not in the way humans need. Most of it is locked as ice beneath the surface or at the poles. Liquid water cannot exist for long on the surface. The pressure is too low. The moment ice melts, it either freezes again or turns directly into vapor. It vanishes. There are brief moments when salty water may flow. Scientists have observed dark streaks on Martian slopes that appear and disappear with the seasons. These are likely briny flows, but they are temporary, unstable, and possibly toxic. This is not. A world where rivers can run freely, even the soil creates problems. Martian dust is extremely fine and electrostatic. It sticks to everything. It can damage equipment. It can cover solar panels. It may even be harmful if it enters the human body, and it is everywhere. The idea of simply building homes and living on Mars ignores all of this. It assumes that the planet is just a harsher version of Earth, but it is not. Mars is missing the invisible systems that make Earth stable. Thick air, protective pressure, heat retention, a natural water cycle. Without these, survival is not just difficult, it becomes a constant battle against the environment itself. Every step outside would be deadly. Every system would need to work perfectly. Every small failure could turn into a life-threatening situation within minutes. The surface of Mars may look calm and silent, but that silence hides a reality that is far more hostile than it first appears, and this is only the beginning of the problem. The human body is not built for Mars. Every cell, every organ, every system inside the body is tuned for one place. Earth, its gravity, its pressure, its environment, change those conditions, and the body does not adapt easily. It starts to break. Mars is only about 38% of Earth's gravity. That might sound like a small difference. It is not. Gravity is the force that keeps the human body functioning in balance. Remove most of it, and that balance begins to collapse. In low gravity, muscles stop working as hard. Over time, they weaken, they shrink. Even simple movements begin to feel different. On Earth, standing, walking, lifting all require constant effort against gravity. On Mars, that resistance is reduced. The body responds by losing strength. Astronauts on the International Space Station already show this effect. After months in microgravity, they lose muscle mass. And bone density, their bones become weaker. Calcium begins to leave the skeleton. This increases the risk of fractures. Mars is not zero gravity, but it is low enough to cause similar damage over long periods, and this damage may not fully reverse. Bone loss can become permanent. Muscles can take months or years to recover. Some changes may never return to normal. A person who spends years on Mars could struggle to even stand on Earth again, but muscles and bones are only the beginning. The heart also changes. On Earth, the heart works constantly against gravity to pump blood upward. In low gravity, this effort is reduced. The heart muscle can weaken over time. Blood flow shifts in unusual ways. Fluids move toward the upper body and head. This creates pressure inside the skull. Some astronauts experience changes in vision because of this. The shape of the eye can shift. Vision becomes blurry. These effects are still not fully understood. Now extend this over years, over generations, the risks grow. The human body also relies on gravity for orientation. Balance systems in the inner ear depend on it. Without normal gravity, these systems become confused. Motion sickness is common. Coordination becomes harder. Even basic movement changes. Then there is the immune system. Studies have shown that space conditions can weaken immune response. The body becomes less effective at fighting infections. Bacteria may behave differently. Some become more aggressive in microgravity. This creates a hidden danger inside any closed habitat. The body is also constantly exposed to stress, not just physical, but biological stress. Hormone levels shift, sleep cycles are disrupted, the natural rhythms that evolved on Earth begin to break down. Mars does not provide the signals the human body expects. No natural air, no stable environment, no familiar gravity. There is no evolutionary path. Each way that prepared humans for this life on Earth shaped the body over millions of years. Mars offers conditions that are completely outside that history. The body has no built-in response for this kind of world. Every day becomes a process of managing damage. Exercise must be constant just to slow muscle loss. Medical systems must monitor changes that are still not fully understood. Small problems can grow into serious health risks. And all of this happens even before considering other threats, because while the body is already struggling to hold itself together, another invisible danger is always present, slowly affecting every cell. There is a danger on Mars that cannot be seen. It has no sound, no warning, no clear sign until the damage is already done. Radiation. On Earth, life is protected by an invisible shield. The magnetic field surrounds the planet and deflects charged particles coming from space. Above that, the thick atmosphere absorbs much of the remaining radiation. Together, they form a barrier that allows life to exist on the surface. Mars has almost none of this protection. Its magnetic field is gone. What remains is weak and scattered. It cannot shield the planet in any meaningful way. The atmosphere is too thin to stop high-energy particles. Space is not far away. It is right above the surface. Cosmic rays travel across the galaxy at nearly the speed of light. They carry enormous energy. When they strike human tissue, they pass straight through cells, breaking molecules apart. They damage DNA directly. This is not like sunlight on Earth. This is constant, deep exposure. Solar radiation adds another layer. The sun releases bursts of energetic particles during solar storms. On Earth, these events create auroras. On Mars, they hit the ground. There is nothing to stop them. A human standing on the Martian surface would be exposed to radiation levels far beyond what is considered safe. Over time, this exposure builds. It does not disappear. It accumulates inside the body. DNA damage begins at the smallest scale, strands break, errors form during repair, cells can become unstable. This increases the risk of cancer, not slightly, significantly, but cancer is only one part of the story. Radiation can also affect the brain. Studies on animals exposed to cosmic radiation show changes in cognitive function. Memory can decline, decision-making can be affected, the structure of the brain itself can change over time. This creates a silent risk for long missions. The nervous system is not designed to handle this level of exposure. Even reproduction becomes a concern. Radiation can damage reproductive cells. It can increase the risk of birth defects. This raises serious questions about future generations living on Mars. A long-term colony would not just face health problems. It could face genetic instability. The obvious solution is shielding, but shielding against cosmic radiation is not simple. It requires thick layers of material. Several meters of rock or dense shielding may be needed to reduce exposure to safer levels. This means habitats would need to be built underground or covered with large amounts of soil. This increases complexity. It increases cost. It limits expansion. Every structure becomes a heavy engineering challenge. Even then, protection is not perfect. Radiation can still penetrate over long periods. Small exposures still add up. There is also the constant risk of solar storms. A strong event could deliver a sudden, intense dose of radiation. Without immediate protection, it could be deadly. Early warning systems would be critical. Safe shelters would need to be nearby at all times. Life would be planned around avoiding invisible waves of energy. This is not a temporary obstacle that can be solved on. Sin, forgotten. It is a constant condition of the Martian environment. It never turns off. It never weakens. And while the body's already struggling with gravity and internal changes, this invisible force continues to act on every cell, every second, adding pressure to a system that is already under stress. The air on Mars is not just different. It is almost non-existent. Stand on the surface without protection and there is nothing to breathe. The atmosphere is made mostly of carbon dioxide, but it is so thin that it barely behaves like an atmosphere at all. The pressure is extremely low. It cannot support human life. It cannot even support liquid water for long. This thin layer of gas fails at something even more basic. It cannot hold heat. On Earth, the atmosphere traps warmth from the sun. It creates a stable range of temperatures where life can exist. Mars has no such system. Heat escapes quickly into space. The surface cools rapidly. Day and night feel like two different worlds. This is why Mars remains frozen. The idea of fixing this has been discussed for decades. It is called terraforming. The concept sounds simple: thicken the atmosphere, trap more heat, warm the planet, release carbon dioxide, store it in ice and soil, let it build up and create a greenhouse effect. On paper, it feels possible. In reality, it runs into a hard limit. There is not enough carbon dioxide on Mars to do this. Scientists have studied the planet in detail. They have measured the amount of gas trapped in polar ice caps and in the soil. Even if all of it were released at once, the pressure would still be far too low. It would not come close to Earth-like conditions. The numbers do not work. This is a lesser-known fact that changes everything. The resources needed to transform Mars simply are not there. Even if a way was found to release every bit of available gas, another problem appears immediately. Mars cannot hold onto an atmosphere. Billions of years ago, Mars lost its magnetic field. That field once acted as a shield against solar wind. Without it, the sun began stripping away the atmosphere particle by particle. This process is still happening today. Any new atmosphere created on Mars would face the same fate. It would slowly leak into space. This is not a short-term issue. It is a continuous loss. The planet itself cannot protect its air. There is no natural system to maintain it. Trying to build a thick atmosphere on Mars is like trying to fill a container with a hole in it. The more you add, the more escapes. And the scale is enormous. To create a stable atmosphere, humans would need to generate vast amounts of gas, not for a short period, but continuously over long time scales. This is far beyond current technology. It is not even clear if it is possible at all. There have been ideas: redirect comets to bring in gases, build massive factories to produce greenhouse gases, use mirrors in space to heat the planet. Each idea sounds bold. Each one faces extreme challenges in energy, cost, and feasibility. None solve the core issue. Mars lacks the internal systems that make a planet stable. It does not have a strong magnetic field. It does not have enough gas reserves. It does not have the ability to retain what it gains. Even if humans create small controlled environments, domes, or underground habitats, the outside world remains unchanged, hostile, thin, unstable. Step outside those protected spaces, and the reality returns instantly. There is no breathable air, no warmth, no natural protection. And maintaining artificial environments forever requires constant energy, constant maintenance, and zero failure. One small breakdown can expose everything to the vacuum-like conditions outside. The dream of walking freely on Mars under an oak end sky depends on a transformation that the planet itself resists at every level. And this resistance is not just environmental. It reaches deeper into the nature of the planet, shaping not only how humans survive, but how they think, feel, and exist over time. Humans did not just evolve bodies for Earth. They evolved minds for it. Every sense, every emotion, every instinct is shaped by this planet. The open sky, the movement of air, the sound of water, the presence of life everywhere. These are not small details. They are part of how the human brain stays stable. They are part of how the human brain stays stable. Mars offers none of this. There is no open air to walk in, no forests, no oceans, no natural sounds. Outside, there is only silence and danger. Inside, there are sealed environments, artificial air, controlled light, recycled everything. Life becomes a closed loop. this kind of isolation is not temporary, it is permanent. On Earth, even in the most remote places, there is still connection to a living world. On Mars, that connection is gone. The environment is not just harsh. It is empty. Psychological studies on astronauts already show warning signs. Even in low Earth orbit, where Earth is always visible below, isolation creates stress. Small crews experience tension, mood changes, sleep disruption, emotional fatigue.
Now, extend that to Mars, the distance alone changes everything. Communication with Earth is not instant. Messages can take several minutes each way, depending on the position of the planets. Conversations lose their natural flow.
There is no real-time connection. This creates a strange kind of loneliness. Even if a person speaks to someone on Earth, the delay breaks the feeling of presence. It becomes more like sending messages into space and waiting. Over time, this can deepen the sense of separation. There is also the fact that returning to Earth is not simple. It requires precise timing, large amounts of fuel, and complex coordination. For long periods, leaving Mars is not an option. This changes how the brain processes reality. The idea of being permanently cut off from Earth is not something the human mind is used to handling. Then there's the question of future generations. Children born on Mars would grow up in low gravity. Their bodies would develop differently. Their bones could be weaker. Their muscles less adapted to strong gravity. Returning to Earth might be difficult or even impossible for them. But the challenge is not only physical. They would grow up without direct experience of Earth, no memory of open skies, no experience of natural ecosystems. Their understanding of life would be shaped entirely by artificial environments. This creates a new kind of human experience, not fully connected to Earth, not fully adapted to Mars, a population that exists between two worlds but does not fully belong to either. This can lead to identity challenges, psychological stress, a sense of displacement that goes beyond anything humans have faced before. Even small things become significant. The absence of wind, the lack of natural smells, the constant awareness that survival depends on machines, every moment is controlled, there is no true escape from the environment. On Earth, a person can step outside, breathe deeply, feel grounded. On Mars, stepping outside without protection means death within minutes. Freedom becomes limitation, can affect how the mind functions, how emotions are processed, how meaning is created. Survival is often described in terms of food, water, and shelter. But for humans, survival also includes mental stability, a sense of connection, a sense of place. Mars challenges all of these at once. And while the body struggles to adapt, the mind carries a different kind of weight, one that grows quiet.
Lying steadily, shaped by a world that was never meant for human life. Mars was not always like this. Billions of years ago, it was a different world. It had a thicker atmosphere. It had flowing water. It may have had conditions that could support life.
For a time, it was closer to Earth than most people realize. Then something inside the planet changed. Mars is smaller than Earth. Its core cooled faster. As it cooled, the internal motion that once generated a global magnetic field began to fade. That magnetic field was not visible, but it was essential. It acted like a shield, protecting the atmosphere from the constant stream of charged particles coming from the sun. When that shield disappeared, the planet became exposed. Solar wind began to strip away the atmosphere, not in a sudden event, but slowly, steadily over millions of years. Particle by particle, the air escaped into space. Lighter molecules went first, heavier ones followed. The pressure dropped, the sky thinned. Water could no longer remain stable on the surface. It either froze or escaped as vapor. Rivers vanished, lakes disappeared, the environment collapsed. What remains today is the result of that long process, a planet that lost its protection. This is where the real limit appears. This is not a problem of building better machines. It is not a matter of stronger materials or smarter engineering. It is a planetary scale issue rooted deep inside the structure of Mars itself. To truly fix Mars, it would not be enough to add air or heat. The planet would need a magnetic field again. It would need a way to protect any atmosphere from being stripped away. That requires restarting processes inside the core of the planet. That is far beyond current technology. Even the most advanced concepts struggle with this idea. Generating a magnetic field on a planetary scale would require enormous energy, and Infrastructure, it would need to operate continuously without failure for extremely long periods. And even then, it is not clear if it would fully work. This is why physicists approach the problem differently. Brian Greene often explains that the universe operates under fixed laws. These laws define boundaries. Inside those boundaries, technology can advance. Outside them, there are limits that cannot be crossed. Mars sits on the wrong side of several of those limits. Its size, its lost magnetic field, its weak gravity, all combine to create a system that does not support long-term atmospheric stability. These are not surface level problems. They are built into the planet's identity. Humans can build habitats, they can create sealed environments, they can survive in small pockets for limited periods. But those solutions exist on top of a planet that remains fundamentally unchanged. Step outside those systems and the full reality of Mars is still there. Thin air, high radiation, extreme cold, no natural protection. Trying to turn Mars into Earth means trying to rebuild processes that took billions of years to form. It means working against the natural state of the planet, and the planet resists. Not actively, but through the simple fact that it follows the rules of physics. Those rules do not bend for ambition. They do not respond to human timelines. Mars is not just difficult, it is stable in its current state. A cold, dry, exposed world that has already lost what it once had. And every attempt to change that runs into the same barrier, the deeper structure of the planet itself. Mars is not just a difficult place to live. It may be a place humans were never meant to survive. Every problem leads to something deeper. Thin air leads to pressure. Pressure leads to biology. Biology leads to radiation. Radiation leads to physics. And physics sets the final boundary. Technology can solve many things. It can build shelters. It can recycle air. It can grow food in controlled systems. For a time, it can keep humans alive in places that were once impossible. But on Mars, technology is always fighting the planet itself, and the planet is not changing. The atmosphere remains thin, the radiation never stops, the gravity keeps weakening the body. The magnetic field is gone. The core systems that make Earth livable simply do not exist there. This is the difference that matters. Mars is not waiting to be fixed. It has already become what it is, a world that lost its ability to support life naturally. This does not mean humans will never go there. Missions will happen, bases may be built. For short periods, survival is possible with enough support, but long-term, self-sustaining life is a different question. That is where the limits begin to appear. Not as obstacles to overcome, but as boundaries that define what is possible, and that leads to a realization that changes everything. Earth is not just a starting point, it is not just one option among many. It may be the only place where human life can fully exist without constant struggle against the environment. The air, the gravity, the protection, the ecosystems, all of it works together in a way that is extremely rare. Leaving Earth is one challenge. Replacing it is something else entirely. The future of humanity may not depend on escaping this planet. It may depend on understanding how unique it really is and protecting it before it is too late. If this changed the way you see Mars and our place in the universe, consider liking the video and subscribing to the channel for more deep explorations like this.